How do we find these if we're given a line? Well, there's a special trick. Finding intercepts. The x-intercept, let y equal 0, will solve for x. So the key thing here is let y be 0 in the formula for our line, and then we're going to solve for x. For the y-intercept, it's reversed. We'll let x be 0. We'll solve for y. So for the x-intercept, we're going to let y be 0. We solve for x. For the y-intercept, we'll let x be 0. We'll solve for y. So we have y equals 2x minus 4. So to find the x-intercept, we're going to let y be 0. And then we just solve for x. So we add -4 to both sides, or add 4 to both sides. Divide both sides by 2. We get x is equal to 2. Now what's happened is we let y be 0. So that means the x-intercept, x comma y, is going to be 2 comma 0. That's how we find the x-intercept. But what about the y-intercept? In this case, we let x be 0. And doing that, as we simplify, we get y is equal to -4. So what this means is that x comma y will be 0 because x was 0, -4. Questions about that? Now, that's one version of the line I have. It's the y equals mx plus b. There are others. There's standard form. So what I can do, I'm going to move this 2x over here by subtracting. I'm going to write it with the x term first. This is called standard form. And standard form is of this form. AX plus BY is equal to C. So let me do an example. Put y equals 3/2 x plus 1 in the standard form. In fact, let me put a minus on here. So I want to move the x term over. So if I add 3/2 x to both sides, we're going to get this. And typically in standard form, I want to try to avoid fractions. So I'm going to multiply everything by 2. So I'll distribute my 2. 2 times 3/2 is 3x. 2 times y, 2y, and this is 2. So that's standard form. Questions about that? All right. Now, there's this thing called the slope of a line. And you can think of slope as sort of like a ramp up. Actually, let me do one more example, though. Let me do one other. Let's find one more example with this. Let's put something in standard form in mx plus b form. So in this case, we want to solve for y. Now I'm going to divide both sides by 2. We're dividing these sides. So another way of saying I divide this side by 2, I'm going to divide every term on that side by 2. Or I could write it with the 2x term first, which will bring the minus sign with it. And that's the final answer. So any questions about that? All right, now moving on to slope. So when we're dealing with these lines, they're going, say, like this. They're doing this. Some of them are perfectly flat. This one doesn't have a slope. This one's sloping down, and this one's sloping up. So what we want to try to come up with is a way of measuring these slopes. Some are steeper than others, some are sloping up, some are sloping down. How do we handle this numerically? Well, there's a mathematical definition for slope. Slope is represented by the letter M. I think what it is, and he might mention it in here. Let me look. I thought it was a Latin word that represented incline. Oh, it's a French word. I'm sorry. So the M comes from the French verb monter, meaning to rise. So there's a French word monter. It means to rise up. And so we use the M in monter to represent slope. That's where that comes from, according to the author. And you've seen this written oftentimes as rise. I'm going to put or fall over run. It's rise or fall over run. Or put another way, vertical change over horizontal change. So it's vertical change over horizontal change. So there's another thing with slope we want to mention is when we measure slope, we always measure it with the horizontal change going left to right. Now you could do it the other way, but you got to be a little careful. So the horizontal change is always measured from left to right. Also, as we're going left to right, if we're going up, this is a positive vertical change. Now, horizontal change turns out to be, if we go from left to right, we always consider that positive. So I'll put a little note here. This is for positive. Vertical change is different, though. You can have up, but you can also have down. And this is a negative vertical change. So you have a horizontal change, a positive vertical change, and a negative vertical change. So let me give you an example. So we have 4 meters and 4 meters. Now the horizontal change again, we measure slope going left to right. And as we're going left to right, we're from a height of 0 to a height of 4 meters. So we get a rise over run, which will be 4 meters, that rises over 4 meters, which gives us a slope of 1. So that's going to be our slope. Let's take a look at another one. Now again here, we always go left to right. Always measure left to right. So in this case, as we go from left to right, we have our run. But then we're going to drop. We'll start at 2 feet and drop to 0. So we have a fall instead of a run. And a fall is going to be negative. So this will be negative 2 feet over 5 feet. Or negative 2/5. Questions about that? So let's put this on a Cartesian plane. So we have these 2 points. 4, 3. And 1 and 1. So as we go left to right, and that's how we always evaluate slope. We evaluate it left to right. Well, how do we find the slope? Well, let's construct our triangle. We can do this. Now here, as we go from left to right, we're rising up. So we start at 1, and we rise up to 3. So we get 3 minus 1, or a vertical rise of 2, from a height of 1 to a height of 3. As for our run, we're starting at 1 and we're running to 4. So this will be 4 minus 1, or 3. So now we consider a rise over run, because now we do have a rise. We definitely do. Well, the rise is 2. The run is 3. So 2/3 is our slope. Questions about that? So this brings up a formula. So it's the slope formula. And it works like this. If we construct our triangle, define the vertical change. Well, it's going to be going from y1 to y2. For the horizontal change, going from x1 to x2. So that distance will be this. So if we take the ratio of vertical change to horizontal change, what we'll get is m is y2 minus y1 over x2 minus x1. And so this is called the slope formula. And so what this lets us do, if we're given 2 points, we don't have to draw a picture. We can just plug in the second y coordinate, first y coordinate, second x coordinate, first x coordinate, and then we can compute the slope. Find the slope between the points 2 and 1 and 5, -3. So one thing I recommend with these questions, label your points. Let's call this one x1, y1, x2, y2. Because the big problem with this is people tend to mix up the x's and the y's between the 2 points. You want to be careful with this. This will be y1, this will be y2. Don't call this one x1. Don't call that one x2. So what we'll get? Oh, it's a y1. And that's what we're going to do. Questions about that? So that's the slope formula. I was minding the time. So I want to summarize some things with slope real quick. One thing. Okay. So types of slopes. Well, not yet. Let's do y equals mx plus b. Now, we've talked about this already. I want to show you where it comes from. And it's this kind of situation. This is called the slope intercept form. What this stands for is a slope of m and a y-intercept. They don't give us the x-intercept, but a y-intercept of 0, comma, b comes from there. So what you get is something roughly like this. So one version of this could look like this. So there's your intercept. And we have a slope of m. I use that to symbolize slope. Then we're going to pick a point on here, any point anywhere. XY. It's any point that's on this line. So what I'm going to do, let's see, I'm going to call this one x1, y1. And, ooh, let me flip this around. I'm going to call this one x2, y2. As long as I'm consistent with the 1 and the 2's, these will be 1s, these will be 2's, that's all right. Whether this is x1, y1, or x2, y2 really doesn't matter. But I'm doing it in this way to show you the formula where it comes from. So now I'm going to plug in everything. Y2 is y. Y1 is b. X2 is just x from here. X1 is 0. Give me a second to write that down. So now I'm going to simplify things. This will be m equals y minus b over x. We're going to solve for y. I'll multiply both sides by x. The x's will cancel here. I'll write this as mx. I'll swap the order. You can do that in multiplication. I'll add the b to both sides. And then finally get mx plus b is y. Or we can write it in the familiar form, y equals mx plus b. So that's where this comes from. Any questions about that? So I just want to mention some quick facts about slope, and then I'll call it for a day. So I'm going to go a little bit over, but not too long. I'll make it quick. So types of slopes or slopes. If m is 3/2, we can think of this as a rise of 3 and a run of 2. If m is -3/2, we always place the negatives on the top number. Excuse me. So with a negative vertical change, this is a fall of 3 and a run of 2. Excuse me. If we have a slope like this, this can be written as 2/1 with a rise of 2 and a run of 1. If we have -2, we say this is -2/1. This will be a fall of 2 and a run of 1. Again, the run's always left to right. But when we get these whole numbers, we put a 1 underneath. For m is 1, it'll be 1/1, or a rise of 1 and a fall of 1. M is -1. We -1/1 with a fall of -1 and a run of 1. And that's it. There's maybe some examples I want to cover in this section. You have x-intercepts, you have slopes. You have the ability to graph. So I think you should be good on this section. The tricky one's going to be 2.5. We've got some more complicated things going on in 2.5, and we'll take a look at that. We are going to do a test with Chapter 1 with Chapter 2. So this is going to be kind of a big exam. Math 107 does tend to be this way. So what I'm going to recommend is it doesn't hurt to do a little bit of a review of Chapter 1, say like over the weekend, just to brush up on it. There's a lot of different topics in Chapter 1 because it's a review chapter, very diverse chapter. So it doesn't hurt to review some things that we've gone over, just so they're not going to be confusing as topics. Because you have exponents, you have, let's see, you had your exponents, you had scientific notation, formulas, solving for x, graphing equations, working with real numbers and things like this, interpreting the English representation of math into mathematical symbols. So it doesn't hurt to review Chapter 1. Maybe take this weekend to do it. We're sort of in the middle of Chapter 2 right now, so that's what I'd highly recommend. And then work on your Chapter 2, and then that'll help you prepare for the test coming up on Chapter 1 and Chapter 2. But that's it for today. Any questions, let me know. I'll be posting this video as soon as I can. And other than that, have a wonderful afternoon. And I'll have office hours starting in about 10 minutes.
Thank you.
No problem.